Hi guys, on the previous video I spoke about a new capability of setting up an internal load balancer as a next stop that work in conjunction with the R81.10 gateway. And this deployment allows us to use the MIG not just for inbound traffic inspection but also for outbound and east-west traffic inspection without the need for a source NAT. What I'm going to show you in this video is basically how to configure such environment, and then I will take it one step further and show you how to build an architecture which span over multiple regions. So I will start from the basics, and first you will need to make sure that your CME version is at least 152. You can check it by running the command on the management cp-info-y all. And if you want to get the latest package and you want to update your CME, you will find the installation package and instruction on the CME SK that you see right now. And here is the topology that I've already created. I deployed a CloudGuard R81.10 MIG. ETH0 is connected to the external VPC. ETH1 is connected to the hub VPC. And I have two additional VPC, one for the QA and another one for the pod. They are paired to the hub VPC. And by the way, if you don't know how to configure the CME and how to deploy CloudGuard MIG, check the video GCP Enterprise Deployment that explain it all. You will find it on Checkmates. So if you will take a look on the VPC peering configuration, you will see that I've set it up in the way that the custom route on the hub VPC are going to be exported to the spoke VPC, pod and QA VPC. And on the pod and QA VPC, the custom routes are going to be imported. So all the routes that I'm going to create on the hub VPC, I'm going to create a default route on the hub VPC. Are going to be populated automatically and imported into the spokes VPC. And what I'm going to do now is to create an internal load balancer. And the target group of the load balancer is going to be the CloudGuard's MIG. And once the load balancer is going to be ready, I will create a default route on the hub VPC that point on the load balancer. This is going to be a default route, the next stop, that point on the load balancer. So let's create the load balancer. I'm going to create a TCP load balancer, but don't worry, it's going to pass all the traffic to the MIG, including UDP and ICMP and any other protocols. If you set it as a next stop, you can find more details in the GCP documentation. And I'm going to place the load balancer in the hub VPC. And now we'll create a new health check. The gateway are going to listen on port TCP port 8117 on both ETH0 and ETH1. And it's being configured as part of the CME, so the gateway are going to listen on that port, and they are going to reply only to GCP probes, health check, that are coming from a specific IP addresses of GCP, and this is configured automatically behind the scenes by the CME. And I'm going to forward all the traffic to the gateways. So Now the load balancer is ready and we can move to the next step and configure the load balancer as a next stop. I will create a new route. I will give it a name and I will attach the route to VPC Hub US. The destination is 0000/0, and the next stop is the internal load balancer that I've just created. Let's give it 5 seconds and then we will check if the route was imported successfully into one of the spokes VPC, QA and prod. And we can see that the prod US VPC got the new default route over the peering, and this means that now that the two spokes VPC got the default route over the peering, that with the appropriate access rule in the checkpoint side, instances in prod and QA will be able to send traffic to each other. And bear in mind that source NAT is not needed for east-west traffic. The instances will be able also to access the internet via the CloudGuard MIG. For this access, source NAT of course is needed. And if we would want to publish an application on prod or QA VPC to be accessible from the internet, we will need to deploy an internet-facing load balancer and publish the application on it. But this is not something new, and I've already explained how to configure it on a video that I've created in the past. Look on Checkmates for GCP enterprise scale deployment. So now that we understand the basic network architecture, let's take it to the next step. Let's assume that your organization has resources also in Europe or any other region in the world. And those two subnets are located in Europe, in Germany. You can connect those VPC to the hub VPC in US by using VPC peering, but it's not a good idea from cost and also latency perspective, as traffic between the prod subnet and the QA subnet in Germany will go through the hub subnet in US. Also, access to the internet or from the internet to those resources will also go through US. And the way to solve it is to replicate the same topology that we used in the US with the minor changes. In order to be able to reach resources from one region to another, I will add to the external VPC a subnet that is located in Germany. The CloudGuard MIG gateways in Germany will be connected with ET80 to the subnet. And I've already created all the VPC and subnet that are located in Germany. And now I will quickly create the VPC peering between the spokes and the hub VPC in Europe. And now I'm ready to deploy the CloudGuard MIG. So let's deploy it. As one CME GCP controller is already configured, I already have a management name on the CME. So I will use the same name. For the template, I will use the name EU-template. The external interface will be connected to the external Germany subnet. The internal interface will be connected to the hub EU VPC and the hub EU subnet, which is located in Germany. In a few moments, we will get the auto-generated SIG, and we will be able to configure the CME template. So this is what we've configured so far, and of course we will need to add an internal load balancer on the hub EU subnet, and then we are going also to add a default route that point on the internal load balancer, and this route is going to be exported to the spoke VPCs on Germany. So let's configure it. Wonderful. So this topology will allow east-west traffic, but only between resources in the same region. So let's extend it to allow resources in one region to talk with resources in another region. And we are going to do that by deploying two internal load balancer on the external VPC, one in the US subnet and another one in the European subnet. This is called an internal load balancer sandwich topology. And let's deploy the two additional load balancers. For the load balancer that we create on the external VPC, we will have to allow global access, as those load balancers are going to get packets that are coming from different regions. Okay, so now we will need to set up the routing. As you can see, the spoke subnet in US use address space 192.168, and the spoke subnet on Europe use 172.16. By default, CloudGuard gateways are being configured to route all the private IP addresses to ETH1 and also as a default route through ETH0. So let's take a look on one of the gateways routing table. So to change the route, what we will need to do is to add to each one of the CME template a unique startup script that configures the required routes. I will prepare a dedicated routing script for each one of the regions. On both scripts, I will remove the private IP addresses routes, and I will add a specific subnet routes that are behind the CloudGuard gateways, and this script should be placed on the management servers. So the two scripts are now ready. And now I will set each one of the CME templates to use his own startup script.
Wonderful. So now I will delete the existing instances from both MIG's groups, and I will let the MIG to create a new instances. And once they are going to be ready, I will check the routing in both instances to verify that the script is configured okay and they got the routes. So now we are good with the routing on the CloudGuard side. Every new instance that will be deployed in each one of the regions as part of the MIG will get its own routes. So the last step is to configure the routing on the external VPC. We will want that traffic with destination 192.168.100.0/22 will route to the internal load balancer on the external US subnet, and traffic with destination 172.168.100.0/22 will be routed to the internal load balancer on the external EU subnet. So let's configure those route, and we are done. So basically this is it. We've completely set up the environment, and now you will just need to configure the checkpoint access rules to allow access between the spokes. You don't need to configure source NAT for intra-region and cross-region traffic, and the recommended way to build the policy would be using the GCP controller on the management and pull the GCP tags to the policy. It's going to make your life much more easier as the policy is going to become dynamic. Last thing is that you probably ask yourself now, why would the route back for traffic between the regions would pass always through the same CloudGuard gateway for the same session? So don't worry, the answer for that is that GCP will handle that by performing session hashing, and they will make sure that always the same gateway will handle each one of the sessions. So I hope that you enjoy this session, and if you have any question, don't hesitate and reply on the post itself. Thank you and goodbye.